Factoring special products. So we're going to start with doing it the way we did on the previous. Oh, that's not a pretty one. I'm actually going to pick a better one. So I'm going to pick x squared minus y squared. And we're going to do this one. So if I look at the two numbers right here, because this x squared Okay, we're going to start with factoring special products. The difference of squares is the product of the sum and the difference of two quantities. So that was when we were doing, oops, I didn't mean to write that. Let's say 3x plus 4, 3x minus 4. And when we did that, we got 9x squared plus 12x minus 12x minus 16. And the middle terms disappeared, so I had 9x squared minus 16. So when you have something that is in this form right here, where the first term is a perfect square and the second term is a perfect square, and they have a minus sign in between, this is called the difference of two squares. So what you're going to be doing on this, you're going to come down here. We are not going to be doing it this, oops, I'm trying to do eraser in it. We're going to look at, because it's only two terms, it's a binomial, and it has a minus sign, has a negative sign. So what we're going to look at is this right here a perfect square? Well, it's the same thing as saying 9v all squared. Then I have my minus sign. And then we're going to look at this one. Oops, I did not mean to do that color. This is the same thing as saying 8w all squared. So, is the first one a perfect square? Yes. Is the second one a perfect square? Yes. Do they have a minus sign in between? They do. So what you're going to do is you're going to take the 9v and the 8w, you're going to put one with a plus sign, you're going to put one with a minus sign. And there you have it. Okay, so let's do it here. If I look at these two right here, are they perfect squares? So 1 is the same thing as 1 squared. 144q is squared is the same thing as 12q all squared. And yes, they have a minus sign in between them. So what you're going to do is you're going to take 1 minus 12q, 1 plus 12q. Now, does it matter which one has the addition and which one has the subtraction? Absolutely not. Okay, so again, it's a binomial. There we go. Is this a perfect square? Is this a perfect square? So this is 5x all squared. This is 8y all squared, and they have a minus sign in between. So that is the difference of two squares. So I take the 5x plus 8y. Notice how I'm just switching back and forth which one has the plus sign and which one has the minus sign, so that you can see it doesn't matter which one has the plus sign and which one has the minus sign. Over here, is this a perfect square and is this a perfect square? So this is the same thing as 14 squared. This is the same thing as g squared all squared. And they have a minus sign in between. Oh, I should make that a different color. There we go. So I take 14 plus g, 14 minus g. And again, it's the commutative property, guys. You can move these around. Either one of these will work. They're the exact same thing. Okay. Now this one says factor more than once. So that means we must be able to do this more than one time. So is this a perfect square and is this a perfect square? Do they have a minus sign in between? Yes. So I'm going to write this as x squared, all squared. I'm going to write this as 16 squared, and I have a minus sign in between. So now in this one, I'm actually going to put the plus first. I'm going to put the addition first. X squared plus 16. And the reason that I'm doing that is because if you look at this, this is still a perfect square, this is still a perfect square, and it has a minus sign. The first one is all finished. We have x squared plus 16. That can't be anything done with it because it has a plus sign. But I can on this one, I'm going to do it over here real quick. X squared minus 16, that's the same as x all squared, 4 all squared, and we have a minus sign in between. That's still the difference of squares. So over here, I'm going to put x plus 4 and x minus 4. So the whole answer is this whole thing. So sometimes you have to go a little bit further. So let's look at this one. Is this a perfect square? Is this a perfect square? Do we have a minus sign in between? Yes, we do. So this is 9n squared. This is 1. We've got a subtraction sign. Oops, I forgot the squared on that. Got the squared on that. So this is going to be 9n squared plus 1, 9n squared minus 1. Then I'm going to look. Is this a perfect square? Is this a perfect square? Is there a minus sign in between? There is. So I have 9n squared plus 1, and I'm not going to change that. And then I have 3n plus 1, 3n minus 1. Okay. Again, is this a perfect square? Is this a perfect square? Does it have a minus sign in between? Yes. So I'm going to write this. 4x to the 4th all squared, y squared all squared with a minus sign in between. So now I'm going to move it around so that you can see that I don't have to write it the way I was writing it. I'll write it with the minus first. Does it matter? It doesn't. I was just doing it so that it was easier to see. Is that a perfect square? Is that a perfect square? And is there a minus sign in between? There is. So I get 2x squared plus y, 2x squared minus y, and then I get 4x to the 4th plus y squared. Again, doesn't matter the order. Okay, we're going to do this volume one. Rectangular solid has a volume of x to the 4th minus 16. Factor the polynomial to find the... Okay, so we're going to factor this. So, is the first one a perfect square? Is the second one a perfect square? And do they have a minus sign in between? So, I get x squared plus 4, x squared minus 4, and look at that. Perfect square, minus sign. So I keep going. X squared plus 4, x plus 2, x minus 2. And there we have it. Okay, perfect square trinomial. Before we do that, I'm going to go back to this. Let's see, 2x plus 3 all squared. When we did this before, now, mind you, you can always do it the x method. You can always factor it like we did before. Remember when we multiply this out, we take the first term and we square it. We take the last term, we square it. And in between, oh, I didn't want to use that color. In between, I take 2 and I multiply that by the 2x and the 3. So I get, I'm just going to simplify it just a little bit. Okay. Oh, I didn't mean to put 9. I meant to put 3 squared. Okay. So the first term is a perfect square. The last term is a perfect square. In the middle, that's what we're looking for. It's the two terms that are perfect squares multiplied together and times by 2. Okay. So if I was to multiply this out, I get a squared, I get b squared. Then in the middle, I have plus 2. Oh, I should have done these in different colors too, just so that it would be easier. Okay, so a b is going to be here, and the a is going to be here. Okay, on this one, the a is going to be squared, the b is going to be squared. We have a plus 2. Again, I did not want to do that. I wanted different colors. So I'm going to take the a and I'm going to take the negative b, and they're going to multiply together. Okay, so here we go. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. Is the middle term this right here? No. So that one, it doesn't work. Let's see. Yeah, that one doesn't work. So this one, is it a perfect square? Yes. Is 1 a perfect square? Yes. Is this the same thing as 6h? This is the same thing as 1. If I took 2 and I multiplied it by 6h and multiplied that by negative 1, would I get the middle term of negative 12h? I would. I forgot the negative 1 on there. Yes. So what does that mean? That means when you factor this, it's going to be 6h minus 1 all squared. Okay. Is the first term a perfect square? Is the last one a perfect square? So let's look at it. 6x all squared. And then I have a 5 all squared. Plus 2. And then in parentheses, oh, I forgot the plus sign over here again. Now, because this is negative right here, that means this should be negative. So if I was to take 6x and I multiply that by negative 5, Would I get this in the middle? Yes, I would. So that means when I factor this, it would be 6x minus 5 all squared. Let's try it again. Is this a perfect square? Is this a perfect square? It sure is. So I'm going to write this as 6x all squared. I'm going to write this as plus 5 all squared. In the middle, no, in the middle, I'm going to have plus 2 parentheses. I'm going to take my first term, and that's 6x. And because, oh, I did it again. This says negative, so this is going to have a negative on it. So negative 5. Well, that's not going to be a perfect square trinomial. Okay, that is not going to work. This one. Is this a perfect square? Is this a perfect square? Yes. So I'm going to take 6x and I'm going to square it. I'm going to take 5, and this is positive, so I'm going to leave it as a positive. And then in the middle, plus 2, parentheses, multiplication in between. I have a 6x. I have a 5. That would get me 60. Yes, that would work. So I have 6x plus 5 all squared. Now, again, guys, you can do it the long way. It's okay.